This video is going to cover section 3.3, Properties of Logarithms, still part of Unit 3, Exponential and Logarithmic Functions. This is a pretty easy subunit, I believe. Some of the stuff you've already seen. We're going to go ahead and start with our change of base formula. And this is basically if we have a log or a natural log that is in one base that we want to convert to a different one. Okay, so we have to let our a, b, and x be positive real numbers such that a is not equal to 1 and b is not equal to 1, first condition. If that's true, then the log of base a of x can be converted to the different bases using these little formulas here. So for base b, meaning just a random base, well, all we need to do is take our log of the x using that base and divide it by log of a, again using that same base, and this will give us the numerical approximation of what that number would be. For base 10, it's really similar to this one, except all we do is divide log x over log of a, because remember that base 10 is the same as just log by itself. Okay, it's the common log. And then for base e, this is our natural log. We have to use our ln notation because this represents our natural logarithm, ln. Okay, let's go ahead and do some examples. These are going to be pretty quick. We do need to use a calculator for these. So I recommend using the Desmos one for this one. We have example number 1, change the base to common log, which is our base 10. So for this first one, I'm going to go ahead and rewrite this as log of 25 over log of 4. Because for the common base, we're looking at the second one here, which just divides this by this in log form. And if we calculate that, we will get, let me go ahead and just remind you how to do that. Here's our Desmos. I'll make it a little bit brighter. So here's our Desmos. We need to go to our Functions button here, and you click on the Miscellaneous. Since we're dealing with the regular common log, let me get a little bit clearer there. Oh, that did not help. There we go. Since we're dealing with the common log, we're going to click on this first one here. So log, and then we have 25, okay, divided by, again, log, so log of 4. And there it is, 2.3219. So this is approximately 2.3219. Okay, same deal with this one. Now we're going to go ahead and do it with these numbers. So we have log of 20 over log of 12. Just plug them in. So based on what I already have here, I can go ahead and just rewrite them. Log of 20 over log of 12, and that's 1.2055 or 0.56. So 1.0, sorry, 1.2, my bad, 1.2056. Okay, and that's basically it, guys. Really, really easy stuff. We have example number 2, which uses the natural log. So same thing, except now we're going to use ln. So it even tells you here, ln. This would be ln of 25 over ln of 4. And this one's going to be ln of 12 over ln of 2. Let's go ahead and do those real quickly. So, oh, let's turn that back the other way. So I'm going to delete all this. And find the ln button, which is also under functions, and it's right on top of the log button. So there it is, ln. Okay, so ln of 25 divided by ln of 4, which is 2.3219. So notice it's practically the same. I would have to go back and look at all the decimal values just to be sure. There's probably going to be a little bit of deviance, but nothing too crazy. Let's try the next one. So ln of 12. You're going to find that this unit in particular, or the homework at least, is going to go by pretty quick. 3.5849. Actually, it should be probably just 5, but that's all right. They're just approximations. And these are different, so they shouldn't be the same. But yeah, there we go. That's it, guys. Just plug it in. Make sure you know how to plug it into the calculator. And if you need any help, let me know. Okay, let's go ahead and move on to the next page. Now we're going to talk about the actual properties of logarithms, which is something you might have seen last year, if not the year before, depending when you took Algebra 2. We have a whole bunch of properties you're going to have to copy here. So I'm trying to get it to see everything here. Let me move this out of the way here. Okay, so we have let A be positive, okay, a positive number, and not equal to 1. Um, N be a real number, and UV also be real numbers such that U is greater than 0 and V is greater than 0. That just means that U and V are positive. Remember, I'm going to start using a little bit more of the fancier notation so we don't have to write so much. And also because you will, if you take any math classes upper level in college, you will start seeing more of these symbols. Okay, so this means positive. If it's greater than 0, it's just positive. Not equal to 1, such that, okay, this little e here means that these belong to the real numbers. Okay. All right, so we have three properties here. We have the product, the quotient, and the power. The product property basically means that if we're multiplying two numbers, again, these are positive numbers with the same base here, we can expand this using addition like so. So what happens is you'll have a log for each of these numbers or terms or whatever they are, and you'll have a plus in between. These rules do stem from the exponents. So if you remember your rules of exponents, when you are multiplying something with the same base, you end up adding them, right? So same deal here. And this is basically the same idea for division, but now we're going to be subtracting. So this becomes subtraction. And then the only one that's kind of weird is this last one, which is the exponent. The exponent just gets moved to the front. So if you have like 5 to the second power, that little 2 is going to move up here to the front. Okay, and the same rules apply for the natural log. Instead of log log, we have ln. That's the only difference. Okay, and here on the side, in case I know it's getting kind of covered, I just have that. This is logarithms with base of a. So you see how we have our base a for all of them. And this is the natural logs, which is all the ln's. Okay, so just some properties. So go ahead and pause here if you need to, so you can copy it. Sorry about the lighting; it's a little bit dim in here today. I have the blinds open, but it's not looking so great today. All right, let's go ahead and jump to a couple of examples here. We have write each logarithm in terms of log 3 and log 5. So let me move this just a little bit back. So I'm not, there we go. So what I'm going to do here is I'm going to see if I can rewrite this 75 in terms of 3 and 5, and then I'm going to, some kind of multiplication or something. And then from there I can expand it, okay, in terms of logs. So let's do it this way. So log of 75, okay, I'm just rewriting it, is the same as log, let's see, I know that 3 times 25 is 75, right? And I also know that 25 is 5 times 5. So 3 times 5 times 5. So that's one way I could do it, right? And if I wanted to use log 3 and log 5, well, now I have 3 and 5. So I can expand this to log 3 plus log 5, because there's multiplication there, plus another log 5. And that's one way I could do this one, okay? I could also rewrite this one since there's two 5s. I could make this 5 squared. I could do 3 times 5 squared. Okay, so let me rewrite it like this. Log, so this is the alternate form, I guess you could say. Alternates. We can say this is equal to log 3 plus log 5. But that power, according to the third rule, I could move it to the front. So plus 2 log 5. So that's another way you could rewrite this one. Okay, basic stuff. Multiplication means addition. Power means it goes to the front of that term. For letter B, same thing. Now we're dealing with log 9 and 125. So I'm going to rewrite this up here first, just for the room. I know that 9 is 3 times 3. And I know that 125 is 5 times 5 times 5. Okay, I'm going to do this one the short way, which is this one right here. This is the same as log, oh, I'm out of space there. Hopefully you can see that. Log of 3 squared, right? And that's going to be 5 cubed. So if I expand this, I'm going to have log 3, but this little 2, and I really hope you can see this, this little 2 right here is going to go in the front, okay? The division means subtract, and again, I have another power, so that power is going to go in front, 3 log 5, okay? And that's basically it for that one. So again, in case you can't see this, the 2, the power is in the front, powers are in the front, the division is subtraction, and that's basically it. All right, moving on. Two more examples here. Now we have evaluate without a calculator. Remember I mentioned this in a previous video. You can definitely check all these answers with a calculator, but if you can do them by hand, do them by hand because I'm going to be looking for that work, okay? For this one, what I'm going to do is I'm going to rewrite this right here in a different format. So log base 5, and I'm going to put 5 to the power of 1/3. Remember that this part right here is the same as that one little power to the 1/3, okay? And then I'm going to go ahead and use my rules of exponents here where I put the power in the front. So that's 1/3 log base 5 of 5. And then from a previous video, I should know that these two right here, so this and this, are equal to 1. So I can kind of like cross this out. And this is equal to 1/3 times 1, which is just 1/3. Okay? Okay, so for example B, we're going to go ahead and do the same concept with the whole kind of sort of canceling. Notice that I circled this right here. Okay, excuse the whiteout. Had some scribbles here by accident. This is the same as 1. So this is actually just gone, right? And the 8, let's do it this way. Let's move the 8 first. So I know that the 8 is going to go in the front, like so, based on my rules. Same thing with this one. The 3 is going to go in the front. And I know that this part right here is just going to be 1. So I have 8 times 1 minus 3 times 1, which is just 8 minus 3, which is 5. And that's it. Easy as that. We are almost done. Nice short video. Well, actually, maybe halfway done. So this part is asking us to rewrite to expand. So here's where we start getting into more of the rules. Remember that multiplication means addition, division means subtraction, powers mean move to the front. Okay, so we're going to go ahead and try that with this one. I have a 4, an x, and a y. So that means I'm going to have 3 logs going on here. 3 different terms, 3 different logs. So let's go ahead and do that. We're going to have 3 logs, all with base 3. So log base 3 of 4, log base 3 of x. I'm not going to put the square, okay? And then log base 3 of y. So I have my 3 different terms here. Now I'm going to deal with whatever else is going on. So the log base 4 doesn't have anything else, so it's basically done. The x does have a square, so that square is going to move to the front. So I'm going to put that 2 right here. And since these two are being multiplied, that's going to be a plus between these guys. Okay? For the y, I'm going to put a little side note here. Y, square root of y is the same as y to the 1/2 power. So that means I'm going to have a power of 1/2, which is going to get moved to the front. Okay? From x to y, you have a division, which means subtraction. And that's it. This is my expanded form for this problem here. Next one, same idea, but now we're dealing with a natural log. This one's a little bit tricky because you see the plus in here, and that tends to make people want to put a multiplication. It's important to note that when you're expanding, okay, you're only changing from multiplication division to plus or minus. So if you have a plus or minus already in this, you're going to leave it. This basically let me color code it. This right here is like one term. This is going to stay together. The 2x plus 7 are just going to move along together. Okay, so let's rewrite it this way first. So ln of, excuse me, 2x plus 7 to the power of 1/2, because remember the square root is a 1/2, all over 8. So I just rewrote it just so we can see a little bit different. We have two things going on. We have this term and we have this term, which means I'm going to have two ln's. And I probably should have made that a little bit bigger, but that's all right. So ln, okay? The first ln is all this, 2x plus 7. I am going to put it in parentheses. The second one is the 8. Since they're being divided here, I'm going to put a minus here in the front. And all I have to take care of now is that 1/2. The 1/2 is with this term, so it's going to go in front of this ln right here. That's it. Done with that one. Okay, that's 1/2 ln. Hope you understand my handwriting there. Okay, moving on. Number 6 and has two parts here. So number 6 is asking us to go backwards. Now we're going to be condensing. Okay, condensing means we're going to go from multiple ones, ln's or logs, to one. So I'm going to just go ahead and start off right with that. So I'm going to have ln, and I have to condense all this. So I'm going to look at the first part here. It looks like this 2, okay, is going to get moved to the power place right here. So there's my first part, x plus 2 squared, okay? I also see that I have subtraction, which means division, okay? And then this x right here doesn't have anything else with it, so the x just kind of stays by itself like that. That's all I can do with this one. And if you wanted to check, well, I mean, just see, we have 1, 2 terms, so I have two ln's up here, division, subtraction, 2 in the front should be a power, so we're good to go. Okay. And last but not least, and then we have one final example after that, is this crazy looking thing here. When we have a power on the out, or I should say a number on the outside, it's going to be a power for the whole thing. Okay, so just keep in mind that this 2 is going to be the power for everything here. So let's start off with the first one. We have log of x plus 3. So log x plus 3. There's no power in front of this one quite yet. Divided by, okay, so subtraction means division, x minus 2. And then that 2 is a squared. Okay, and all of this is with the power of 2. So all of this, I'm going to go ahead and put in parentheses and put a power of 2. So something like, I guess you can do it like this, but basically the 2 is just going to go to my parentheses. So right here and right here. Okay, so this is going to be log x plus 3 squared all over x minus 2 to the 4th power. Because when you're distributing power to power, you're actually just multiplying. And that is it for that one. Okay. And that's it, guys. This is a pretty basic set of notes. We have one more application problem that I wanted to show you, and it's kind of a long one, so hopefully it doesn't take too long. But here we go. If we are trying to find an equation, okay, so this is usually based on some of the applications. You'll probably have one or two of these in your homework. If we're trying to find a logarithmic equation that relates y and x for some set of data, so this is the data that I happen to pick from the examples. What we're going to do is we're going to start off by making a table, okay? Generally, what you want to do is you want to graph this and you want to see more or less what the regression line will look like. But since we don't really have those kind of graphing utilities, we're going to use ln to help us. So step one is to make an ln table. And here's how it works. You take the ln of all the x's, the ln of all the y's, and then you're going to find the slope for that, okay? Because this should be a line. So here's how this would look. I did this in 2 steps so you can see what I'm doing. So my x's are going to be all the x's that I have here. So ln of x would be ln of 0.37. That's this one. ln of 1.0, that's this one, ln of 2.72, ln of 7.39. Hopefully you get the idea by now. 7.39. I'll probably fast forward the video in just a bit because this does take a little bit of time just to write out. 20.09. Okay, so those are all my x's. Let me zoom out a little bit so you can see what I'm doing here. And now I'm going to do the same thing with the y's. So now I'm going to take my y's and I'm going to put the ln of those also. So ln of 0.51, ln of 1, ln of 1.95, ln of 3.79, okay, and ln of 7.39. And basically all we're going to do is we're just going to plug those into the calculator and see what the values are. So that's why I kind of have another table here that shows this is the ln stuff and this is going to be the approximated decimal, I should say. So let me go ahead and do that really quickly. And I can show you one so you can kind of see what I'm doing here. And then I'll probably fast. Okay, so these are the values that I got, and I'm just gonna show you one just so you can see how you do it real quick. So let's say you want to do this one, ln of 0.37. You go to your functions again, go to your miscellaneous, click on ln 0.37, and there it is, negative 0.994. Okay, and oh, I forgot the negative. It's a good thing I double checked, huh? There you go, negative 0.994. Okay, and same thing with all the rest of them. So after you do this, typically what you want to do is you want to kind of do a quick little plot just to see what kind of function this looks like. I'm pretty sure it's a linear, but let's just really quickly here on the side, or actually we can just do it right here. It won't take long. Just kind of quickly sketch it. So it looks like we have, and I'm just going to, like I said, kind of round where these are going to land. I have a 0, 0. I have negative something maybe here, 1 something there, 2. It's kind of going a little bit up there, 3, 2. So you can kind of see it is going to be somewhat of a line. Okay, so because of that, I'm going to use something along the lines of a linear model. Okay, so step 2, and this one is to calculate based off that linear model the slope. Okay, so for slope, we want to pick two numbers that are, not too difficult to calculate, and we want to subtract the y's, put those on the top, subtract the x's, and put those on the bottom. So I'm going to use the easy ones because why not? So I'm going to use 0, 0, and I'm going to use 3, 2. Because those seem like pretty easy numbers to work with. I don't even have to use a calculator for those. So for my y's, I would have 2.00 minus 0. For my x's, 3.000 minus 0, which is 2/3. Okay, so my slope is 2/3. And then I'm going to use my point slope formula to find the equation. So this is back from chapter 1. Y minus y1 equals m times x minus x1. And of course, because I'm being lazy, I'm going to use the easiest point of 0, 0, and my m is 2/3. So when I plug everything in, it comes out super nice. So let's see, y minus 0 is equal to 2/3 times x minus 0. So when I simplify this, I just end up with y equals 2/3 x. And we're kind of sort of done, okay? But the question was to write a relationship that relates the logarithmic equations, so the logarithmic equation for y and x. So what I'm going to do is I'm going to rewrite this. Remember that this y was ln of y, okay? And this x was ln of x. So I'm just going to replace that like so. So my final answer for this will be ln of y equals 2/3 times ln of x. And I am done with this example and with the video. If you have any questions, as always, let me know.